Welcome everyone. I'll be talking about the Bits Watts Institute today, which is one of the initiatives under the Precourt Institute for Energy. And the goal of Bits Watts is one, which is how can we move towards a sustainable, resilient, and equitable energy system, in particular in what concerns the grid. So we do have that we need energy to grow, and we all know that. And though there have been enormous developments in terms of an increase of renewables and share to the increased share of natural gas, the fact is that we still rely a lot on fossil fuels to provide all these services that we enjoy. And relatedly to that, the impacts of climate change are already being felt and upon us. What the animation will show is that over time, what have been the anomalies in different countries when compared to a certain baseline. And you'll see that as time lapses by, we'll see more and more of the red dots, meaning high temperature anomalies departing from that. So we'll need to start thinking, in particular in the context of the grid, how to cope with those effects of high temperatures, how to build a grid that is resilient, and how to mitigate the potential damages associated with operations and failures in the grid. At the same time, we are definitely not on track yet in terms of emissions reductions to the extent that is needed. So when I look at the projections in terms of GHG emissions, those are continuing to steadily grow. And so the window to have any chance to avoid a temperature increase of less than 1.5 degrees C is rapidly closing. So what can we do about it? Well, one of the things that Bits Watts is doing is to enable and produce tools that allow for better decision making. How can we do that? Well, the first thing would be to track the emissions and understanding their flows. What you're seeing in the screen is a tool that has been put together by Bits Watts to understand what are the consumption-based emissions for each US balancing area in real time. And actually, if you go to the lobby in the screen that is out there, you can see the current emissions as well as electricity generation for each balancing area across the United States. So this provides a good picture of emissions intensity for CO2. But then what can we do about it? Well, the other tool that we've built is a carbon abatement supply curve. What this does is that it characterizes the emissions of every single power plant in the United States. And for that same location, assesses what would be the best alternative in terms of newly built infrastructure, whether natural gas combined cycle power plant or wind or solar coupled with storage. We assess the cost of such, and we do so under a very wide range of scenarios, so changing fuel prices, changing the time horizon for which we'll do these decisions, and so forth. The animation that you're seeing is the abatement supply curve that could be pursued for the United States, and we also provide that by region and by state in the hopes of guiding the future expenditures on built infrastructure for the grid. Now, when you think about fossil energy, and in particular the grid, it's not enough to have one problem, right? So we have one problem, which is the climate change with the global dispersion of greenhouse gases. But the other problem is that the combustion of fossil fuels is going to lead to criteria pollutant emissions. And those criteria pollutants will have damages in terms of inducing premature mortality from breathing polluted air. So when we start thinking about a sustainable future grid, we may want to consider those two aspects, which begs the question, are we all breathing the same air, and what is the pollution that comes from the power sector? Well, we looked at that too, and we looked at that under the lenses of environmental justice. What you see here is on the vertical axis, premature mortality per 100,000 people associated with the emissions from power plants across the United States. And you'll see that parsing out by income level. We see that for high-income households are located in places where the air is a little bit better, and so the premature mortality is slightly lower. But what we see too, when we analyze this data by race as well as income, is that Black African American across all levels of income are exposed to more pollution and more premature deaths than white, non-Latino, or other groups as represented by the census. So this again begs one next question, which is when we're thinking about decarbonization policies for the power sector, should we consider also the co-benefits that we'll have in terms of health damages? How does that change the answer? So we looked at that too, and so we accounted for the costs and the benefits of transitioning from the current grid to alternatives like wind and solar or natural gas combined cycle. In order to do that, once again, we parsed out vast amounts of data to have hourly output from wind and solar as a way to simulate how large of a storage device would we need to couple with wind and solar in those same locations. The orange bars show the benefits that we would have in terms of climate mitigation reduction, the blue ones in terms of health damages that are avoided with those transitions, and the green bars represent the cost of building and operating this entire new infrastructure. The diamonds show the net benefits. What this means is that if we were to internalize the societal damages that we're imposing by having the system as we do, we'd have a net benefit in terms of moving to this transition. But since this stuff is not priced in the markets or not at the level of the implications that they have in terms of costs, we don't see some of those changes materializing. Now, the other portion of this that Bits and Watts focus on is we need to electrify everything that we can electrify. And so this begs the question, is electrifying transportation the best solution for the United States and elsewhere? So we looked at that in a life cycle perspective. This plot shows for a few recent models the comparison between battery electric vehicles and hybrid vehicles, both from vehicle manufacturing, battery manufacturing, as well as charging those vehicles. And one of the things that you'll notice is that actually some of the battery electric vehicles may have higher life cycle emissions than hybrid gasoline vehicles. And so why is that? Some of this penalty is just the manufacturing of the battery and with larger batteries. Some of that ties to inefficiencies of the battery when charging. But fundamentally, this drives to the electric vehicles only being as clean as the grid that is going to be used to charge them, as we've seen in the transportation section. So that, again, begs the question, can we look at where the grid is now clean enough for us to adopt electric vehicles? All the areas that are shown in white are locations where vehicle electrification already reduces emissions more than hybrid vehicles. Whereas the areas that still have some color represent areas where the critical emissions factors, which we define as the level of emissions intensity of the grid that needs to be achieved for electrification to make sense. Now, all this analysis for the life cycle accounts for charging the vehicles with convenient charging when you get home at night. But we need to understand better how people decide to charge their vehicles. And so work from Bits and Watts under an initiative called EV50 focus on trying to understanding observed behavior from a lot of users on their charging patterns and clustering it as to represent how this domain is likely to evolve under a larger adoption of EVs and larger loads. We then coupled that information with hourly emissions at the margin, both in the current grid and future grid scenarios. And we found one key takeaway message that was already highlighted also this morning. Charging during the day and thus having workplace charging in the Western United States makes the most sense if your goal is to reduce emissions. And so policies will need to be aligned with that. So with that, this is hopefully a few examples of recent research and output from Bits and Watts. And with that, we'll move on to our esteemed panel. Thank you.